For homework 11, 8.35a, the problem is water is flowing at 2 kilograms through a 2 kilograms per second through a 40 millimeter diameter tube and is to be heated from 25 to 75 degrees Celsius by maintaining the tube surface temperature at 100 Celsius. What is the required tube length for these conditions? So our givens are the mass flow rate, the diameter, the temperature coming in of the fluid, the temperature coming out of the fluid, and when we have the temperature film, which is the average of these two, which is 323 Kelvin after you convert from Celsius. The surface temperature is 100 degrees Celsius of the tube. Now the thing to remember here is that it's constant surface temperature, which means that we will be using a different Nusselt's number if it's laminar, and it also means that we need to use different equations for our enthalpy, H. So here are the givens from the book. You have to get these from the book, so these are all in blue because you have to find them. And we will be using only the specific heat and the Reynolds number. I think that's it. Well, let's go over to the problem. So in order to find our length equation, we will be using the mass flow rate, which we know, the CP, which we found, and then the log of this two differences in temperature divided by pi, the diameter, and our enthalpy that we have to find. So we need to find CP, which we got. CP was 4,181 joules per kilogram Kelvin, and our H equation is here. Our H equation requires us to find the Nusselt's number, which we do not know. So then we plug it into the Nusselt's number. The Nusselt's number, we need to determine if it's turbulent or if it's laminar. So to determine turbulent or laminar, we need to plug into the Reynolds number equation. The Reynolds number equation gives us these requirements, which we have all now. So it gives us a 116,383 value for Reynolds number, which is over 10,000, over 2,300. So that means it's turbulent. If it's turbulent, that means we can't use the given laminar value for constant heat flux or for constant temperature surface. So from there, we have to plug it into the actual equation and solve for the Nusselt's number. So we plug it into this equation. PR, we know it's given, and we're going to use 0.4 because it's heating. And so here we have the value. We get 431.54. Now that we know the Nusselt's number, we can plug in here, get the specific, or we get our K value divided by the diameter, gives us this value. And then this value we're able to use when we're dividing. Ignore the blue, this isn't incorrect. When we plug this in, we'll get a value of negative. We get a value of negative 10.53. And that's the length that is required for these conditions.